Selenium Security for Beginners Introduction. Selenium security means using Selenium safely when writing browser automation tests, especially when tests involve login, credentials, cookies, tokens, test data, CI/CD pipelines, browsers, and remote Selenium Grid. Selenium is commonly used for key web UI automation, key end-to-end testing, regression testing, key cross-browser testing, key login flow testing, key form testing, key admin dashboard testing, key cloud testing, CI/CD test automation. A common learning topic is, how can beginners use Selenium securely? This guide explains double-click Selenium basics, security risks, browser automation safety, credentials handling, test data protection, cookie token safety, Selenium Grid security, CI/CD security, Docker security, test environment security, logging security, screenshots, video security, best practices, interview questions. Selenium WebDriver drives a browser as a user would, either locally or on a remote machine using Selenium Server. Selenium Grid allows tests to run on remote machines by routing commands to remote browser instances. Because Selenium can interact with real browser sessions, security must be considered carefully. Simple definition. Selenium security means making sure Selenium tests do not expose passwords, tokens, cookies, private data, test environments, or internal systems. Simple idea. Selenium test opens browser, logs into app, uses test data, captures logs/screenshots, runs in CI/CD. Security question. Are secrets, tokens, screenshots, logs, and test data protected? Why Selenium security matters. Selenium tests often touch sensitive things. Click login credentials, JWT tokens, cookies, session data, admin pages, customer-like test data, screenshots, browser logs, CI/CD secrets, test environment URLs. If handled badly, passwords can leak in logs, tokens can appear in screenshots, test data can expose private information, remote Selenium Grid can be abused, CI/CD artifacts can reveal secrets, tests can accidentally run against production. Selenium architecture overview. Typical Selenium flow: test code, WebDriver, browser, application under test. Remote Selenium Grid flow: test code, remote WebDriver, Selenium Grid, remote browser node, application under test. Security sensitive areas: copy test code, copy WebDriver configuration, copy browser profile, copy credentials, copy screenshots, copy logs, copy CID pipeline. Core Selenium security areas. Area security concern: credentials, passwords leaking in code/logs, tokens, JWT/cookies exposed, screenshots, sensitive UI captured, logs, secrets printed, test data, real user data used, grid, remote browser exposed, CI/CD, secrets artifacts leaked, browser profile sessions stored, network HTTP instead of HTTPS environments, tests accidentally hit production. Step 1. Never hardcode credentials. Bad. Driver.findElement, by ID email.sendkeys, admin@example.com. Driver.findElement, by ID password, sendkeys, admin password 123. Problem. Password is visible in source code. Password can be committed to Git. Password can leak in code review. Better. String email equals system.get.env test user email. String password equals system.get.env test user password. Driver.findElement, by ID, email, send keys email. Driver.findElement, by ID, password, send keys password. OOP CI/CD security guidance says secrets should not be printed to console, logged, stored in command history, or persisted in clear text as a consequence of pipeline use. Step 2. Use CI/CD secrets. Use secret storage in GitHub Actions secrets, GitLab CI/CD variables, Jenkins credentials, Azure DevOps variable groups, AWS secrets manager, Vault, Kubernetes secrets. Example, GitHub actions. Env, test, user email. $, secrets test user email. Test user password, $, secrets test user password. Java test, string email equals system get env, test user email. String password equals system get env, test user password. Rule, test code reads secrets. Test code does not store secrets. OWASP Secrets Management Cheat Sheet also covers CI/CD hardening and managing secrets used by build, test, deploy systems. Step 3. Never print passwords. Bad. System.out.println password plus password. Better. System.out.println password configured plus password is null. Safe logging. Test user email configured. True. Test user password configured. True. Unsafe logging. Key S user password equals actual password. Step 4. Use test accounts only. Do not use real customer accounts. Bad. Use real production admin account for Selenium tests. Better. Use dedicated test user with limited permissions. Recommended test users. Test user at example.com. Test admin at example.com. Test read only at example.com. Test manager at example.com. Each test account should have cask, limited permissions, no real payment data, no real customer data, easy reset process, environment-specific access. Step 5. Avoid production testing unless approved. Bad. Selenium test creates, deletes data in production. Better. Run Selenium tests in dev, QA, staging, or test environment if production smoke tests are required. Read-only checks only. No destructive actions. No real user data exposure. Separate test account. Explicit approval. Clear monitoring. Rollback safe behavior. Step 6. Protect cookies and tokens. Selenium can access cookies. Set cookie cookies equals driver.manage.getCookies. Do not print them. System.out.println cookies. Risky. Why? Cookies can contain session identifiers. Session identifiers can allow account access. Better. System.out.println cookie count plus cookies.size. Never log. XX session cookies. XX JWT tokens. XX refresh tokens. XX CSRF tokens. XX authorization headers. Step 7. Clear browser state after tests. Tests can leave behind cookies, local storage, session storage, cache data, logged in sessions. Cleanup example. Driver, manage, delete all cookies. JavaScript executor driver, .execute script, window.localstorage.clear. JavaScript executor, driver, execute script, window.sessionStorage clear. Use cleanup. At after each, void teardown, driver.manage.delete all cookies, driver.quit. Avoid using your personal browser profile. Bad. Run Selenium using your normal Chrome profile. Why? Bad. Personal cookies, passwords, and sessions may be exposed. Better. Use clean temporary browser profile for automation. Example Chrome options. Chrome options equals new Chrome options. Options.add arguments, incognito. Even better. Use fresh browser session per test run. Step 9. Do not save passwords in browser. Disable password save prompts where possible. Chrome example. Chrome options equals new Chrome options. Map string object. Prefs equals new hashmap prefs. Prefs.put credentials enable service, false. Prefs.put profile.password manager enabled, false. Options.set experimental option, prefs. Why? Automation browsers should not store login credentials. Step 10. Be careful with screenshots. Screenshots can contain check. usernames, emails, personal information, tokens shown in UI, admin pages, private dashboards, order data, customer-like data, example screenshot. File screenshot equals take screenshot driver, get screenshot as output type.file. Best practices. 1. Capture screenshots only on failure. Avoid sensitive pages if possible. Mask sensitive test data. Store artifacts securely. Expire old artifacts. Restrict access to CI artifacts. Step 11. Be careful with videos. Some Selenium Cloud Grid tools record videos. Videos may show login flow, typed email, admin data, private forms, test accounts, internal URLs. Best practices. CURP, disable videos for sensitive tests if not needed. Restrict video artifact access. Set retention limits. Avoid using real personal data. Mask data in test environment. Step 12. Secure test logs. Logs can leak sensitive data. Bad log. Logging in with admin at example.com, password 123, JWT token, EYJHBGCIOI. Good log. Logging in with configured test user. Login successful. Safe log pattern. Log info. Login test started. Log info. Login result success. Avoid logging. Next. Passwords. Tokens. Full cookies. Full request headers. Full private profile data. Raw API responses with sensitive data. Step 13. Use fake or masked test data. Bad. Real customer names, addresses, phone numbers, payment details. Better. Binned. Synthetic test data. Example. Test user 123 at example.com. 123 Test Street. Use fake data for count, profiles, orders, addresses, comments, messages, search tests, admin dashboards. Step 14. Test data cleanup. Selenium tests often create data. Example. Create user, create order, create product, upload file. Clean up after test. Delete created records. Use unique test IDs. Reset database state. Use test environment. Isolate test tenant. Expire test data automatically. Example naming. Auto test order 22606-001. Why? Easy to find and delete test data. Step 15. Avoid overprivileged test users. Bad. All tests use superadmin. Better. Each test uses minimum required permission. Examples. Test user. Red profile, normal user. Create product, product admin. View reports, report user. Admin, user management, admin, test user. Principal. Least privilege. Step 16. Secure Selenium Grid. Selenium Grid allows remote browser execution. That is useful, but risky if exposed. Selenium's Grid documentation describes Grid as routing WebDriver commands to remote browser instances. The Selenium project also published guidance about protecting unsecured Selenium grids, which is a strong reminder not to expose Grid without controls. Bad. Public internet means Selenium Grid. Better. CI runner, VPN, internal network means Selenium Grid. Secure Grid with Ducks, private network, authentication proxy, firewall rules, VPN, limited access, container isolation, logging and monitoring, no production secrets in browser sessions. Step 17. Do not expose WebDriver ports publicly. Browser drivers and WebDriver endpoints allow controlling browsers. Risk. If exposed, unauthorized users may control browser sessions. Best practices. Check. Bind to localhost private network. Check. Use firewall rules. Check. Avoid public ports. Check. Run in isolated CI workers. Check. Destroy sessions after test. Keep drivers updated. Step 18. Use HTTPS test environments. Bad. http://test.example.com/login Better. https://test.example.com/login. Why? Protects login credentials in transit, mirrors production behavior, catches certificate security issues, avoids insecure cookie problems. Use HTTP only for local development when needed. Step 19. Be careful disabling browser security. Sometimes, test code disables browser security. Example risky flags. Disable web security. Ignore certificate errors. Allow insecure localhost. Use only when. Local development, temporary debugging, controlled environment. Avoid in X. Production-like tests. X. CI security validation. X. Real login flows. X. External sites. Step 20. Keep Selenium and browser drivers updated. Outdated tools can cause compatibility errors, flaky tests, security concerns, browser startup failures. Selenium documents common WebDriver errors, including browser and driver version mismatch. Best practices. Use Selenium Manager or pinned compatible drivers. Update Selenium regularly. Update browser images. Avoid random untrusted driver downloads. Download from official sources. Track dependency vulnerabilities. Official Selenium downloads are listed on Selenium's downloads page. Step 21. Secure CI/CD pipeline. Selenium tests commonly run in CI/CD. Pipeline risks. Check. Leaked secrets, public artifacts, insecure runners, overprivileged tokens, untrusted pull requests, logs exposing tokens, test reports exposing data. OWASP's CI/CD security cheat sheet recommends protecting secrets and ensuring they are not disclosed through logs or persisted in clear text during pipeline use. Secure CI/CD by across. Using secret stores, masking secrets, limiting artifact access, restricting test environment access, using least privilege tokens, not running secret using tests on untrusted PRs, cleaning workspaces, rotating credentials. Step 22. Do not run secret tests on untrusted pull requests. Risk. External PR modifies test code to print secrets. CI runs tests with secrets. Secrets leak. Safer approach. -ec. Do not expose secrets to forked PRs. Run limited tests for untrusted PRs. Require approval for secret using jobs. Separate trusted and untrusted pipelines. Review test changes carefully. Step 23. Secure Docker Selenium. Docker Selenium tests may use best practices. Carc. Run containers with limited privileges. Carc. Avoid mounting host secrets. Carc. Avoid privileged mode. Carc. Use private networks. Carc. Remove containers after tests. Carc. Keep images updated. Carc. Scan images for vulnerabilities. Bad. Privileged. True. Unless truly needed. Better. Use least privilege container configuration. Step 24. Secure cloud Selenium providers. Cloud browser testing tools may record. Check logs. Check screenshots. Check videos. Check network data. Check test metadata. Best practices. Use test accounts only. Avoid real sensitive data. Restrict team access. Check retention settings. Disable videos for sensitive tests if needed. Protect provider API keys. Rotate provider access keys. Step 25. Avoid automating real third-party accounts. Bad. Use personal Gmail, Facebook bank account in Selenium tests. Better. Use sandbox, test accounts, and test environments. Why? Check. Avoids account lockouts. Avoids exposing private data. Avoids violating terms. Avoids unpredictable MFA security checks. Avoids real-world side effects. Step 26. Handle MFA safely. For apps with MFA. Better testing options. Click Test-Specific MFA Bypass in lower environments. Click Test OTP Endpoint Restricted to QA. Click Mock Identity Provider. Click Seeded Test Codes. Click Sandbox Identity Provider. Click Backend Integration Test for MFA logic. Avoid. Note. storing real personal MFA backup codes, automating someone's personal account, disabling MFA in production, logging OTP codes. Step 27. Avoid CAPTCHA bypass. CAPTCHA exists to stop automation for your own application testing. Disable CAPTCHA only in test environment. Use test keys provided by CAPTCHA provider. Mock CAPTCHA verification in QA. Test backend verifications separately. Do not design tests that bypass protections on third-party sites. Step 28. Secure file upload tests. File upload tests can be risky. Use safe test files, small files, non-sensitive content, restricted upload directories, cleanup after test, validation checks. Avoid uploading no real documents, no private images, no secrets, no executable files, unless specifically testing security in a controlled environment. Step 29. Validate security features with Selenium. Selenium can test some security-related user flows. Examples. Check login redirects, logout clear session, unauthorized user cannot see admin page, CSRF protected form works, session timeout redirects user, role-based menus are hidden, password field masks input, secure pages require authentication. Important. Selenium does not replace security testing tools. It can verify security behavior from the browser. Step 30. Selenium is not enough for security testing. Selenium is good for UI automation, but security testing also needs check SAST, dependency scanning, DAST, API security testing, secret scanning, threat modeling, manual security review, penetration testing for approved environments. Selenium answers. Does the UI behave as expected?
Security testing answers.
Can the system be abused or broken? Selenium security with Spring Boot example. Architecture. Selenium test, Chrome browser, React Angular app, Spring Boot API, database. Security test cases. Unauthenticated user redirected to login. Normal user blocked from admin page. Admin user can access admin page. Logout clear session. Expired token redirects to login. Sensitive fields not visible. Password field uses type password. Example. Test unauthorized access. At test, void normal user should not access admin page. Login as test user email, test user password, driver.get base URL plus admin. Web element error message equals driver.find element by ID access denied message. Assert equals access denied error message.get text. Security meaning. Frontend should block redirect normal user. Backend must also enforce authorization. Example, test logout clears session. Test void logout should redirect to login. Login as test user email, test user password. Driver.find element by ID, logout button, click. Driver.get base URL plus dashboard. Assert true, driver.get current URL contains login. Also verify. Cookies cleared. Local storage cleared. Token removed. Protected API returns 401. Example. Test password field masking. At test, void password field should be masked. Driver.get base URL plus login. Web element password equals driver.find element by.id password. Assert equals password. Password.get attribute type. Simple security UI check. Password should not be visible as plain text by default. Example, safe login helper private void, login as string email endname, string password endname, string email equals system.getm, email endname, string password equals system.getm, password endname. If email equals null or password equals null, throw new illegal state exception. Test credentials are not configured. Driver.find element by ID email, send keys, email. Driver.find element by ID password, send keys, password. driver.findElement by id.login button. Click. Notice. No password printed. No hard-coded secret. Selenium security checklist. Before running Selenium tests, check. No hard-coded passwords. No tokens in logs. No real customer data. Test accounts only. Least privileged users. Test environment URL correct. Screenshots secured. Video secured. CI secrets protected. Grid not publicly exposed. Browser sessions cleaned up. HTTPS used when possible. Access secrets. Artifacts have retention limits. WebDriver browser versions updated. Common beginner mistakes. 1. Hard-coding login credentials. Bad. Send keys. Admin password. Better. Send keys. System get env. Test user password. 2. Printing tokens. Bad. System.out.println. Local storage.getItem access token. Better. System out println access token exists plus token exists. 3. Using real user data. Bad. Real customer records in test screenshots. Better. Synthetic test data. 4. Public Selenium Grid. Bad. Selenium Grid exposed to internet. Better. Selenium Grid behind private network/VPN/authentication. 5. Leaving browser sessions open. Bad. Test fails and browser keeps session active. Better. Driver.quit. In cleanup. 6. Running destructive tests against production. Bad. Delete user test runs on production. Better. Destructive tests only run in test/staging environment. 7. Uploading sensitive screenshots. Bad. CI artifact contains admin page with private data. Better. Use fake data and restrict artifact access. Best practices. Can use environment variables or secret managers. Can never hardcode credentials. Can never log passwords, tokens, cookies. Can use test accounts only. Can use least privileged test users. Can avoid real customer data. Can clear cookies local storage after tests. Can use fresh browser profiles. Can secure screenshots and videos. Artifacts. Protect Selenium Grid. Avoid exposing WebDriver ports. Use HTTPS in test environments. Keep Selenium browser drivers updated. Do not use personal accounts. Handle MFA through safe test-only design. Separate security checks from normal UI tests. Use Selenium to verify security behavior, not replace. Security testing. Selenium security interview questions. 1. What is Selenium security? Selenium security means safely designing and running Selenium tests so credentials, tokens, cookies, screenshots, logs, test data, and test environments are protected. 2. Why should credentials not be hard-coded in Selenium tests? Because hard-coded credentials can leak through source code, Git history, logs, screenshots, and code reviews. 3. How should Selenium tests access credentials? Use environment variables, CI/CD secrets, or a secure secret manager. 4. Why should Selenium tests use test accounts? To avoid exposing real user data and to prevent real-world side effects. 5. What is the risk of logging cookies? Cookies may contain session identifiers that can allow account access if stolen. 6. What is the risk of screenshots in Selenium? Screenshots can capture sensitive UI data such as emails, admin dashboards, tokens, private messages, or customer-like information. 7. How do you secure Selenium Grid? Run it on a private network. Restrict access. Use firewall/VPN/authentication. Isolate containers. Monitor usage and avoid public exposure. 8. Should Selenium tests run against production? Usually no. Run against dev, QA, or staging. If production smoke tests are needed, keep them read-only and tightly controlled. 9. How do you clean browser state after tests? Delete cookies, clear local storage, session storage, and quit the browser session. 10. Why avoid personal accounts in Selenium tests? Personal accounts can expose private data, trigger security systems, and create unpredictable test failures. 11. Can Selenium replace security testing? No. Selenium can verify browser-level security behavior, but it does not replace AST, DAST, API security tests, dependency scanning, secret scanning, or security reviews. 12. What security behavior can Selenium test? It can test login redirects, logout behavior, role-based access UI, protected pages, password field masking, session timeout, and unauthorized access flows. Selenium Security Roadmap, beginner level. Learn. Okay. Selenium Basics, WebDriver, login tests, environment variables, test accounts, screenshots, cleanup. Build. Secure login test using test credentials, intermediate level. Learn. CI/CD secrets, artifact security, browser state cleanup, role-based tests, logout session tests, Docker Selenium. Build. Secure Selenium test suite in CI/CD advanced level. Learn. Check. Selenium Grid security, cloud browser testing security, token cookie handling, MFA test design, test data isolation, production smoke test safety. Build. Enterprise safe Selenium automation framework, 30-day learning plan week 1, Selenium basics. Learn. WebDriver, browser automation, locators, login test, setup, teardown, screenshots. Practice. Create login test with test user. Week 2, secure test data. Learn. Environment variables, fake data, test users, least privilege, cleanup, no secret logging. Practice. Create secure test data strategy. Week 3, CI/CD security. Learn. Check. CI/CD secrets, artifact protection, screenshots, videos, untrusted PR risks, Docker Selenium basics. Practice. Run Selenium securely in GitHub Actions Jenkins. Week 4, Grid and Advanced Security. Learn. Check Selenium Grid. Check remote browser security. Check cloud testing providers. Check MFA test strategy. Check token cookie risks. Check security behavior tests. Practice. Build secure role-based Selenium test suite. Real-world project. Secure Selenium test framework for Spring Boot app. Architecture. Selenium Java tests, TAS, Chrome WebDriver, React Angular frontend, TAS, Spring Boot API, TAS, PostgreSQL. Features. Login test, logout test, role-based access test, admin access test, normal user block test, screenshots on failure, no secret logging, CI/CD secret usage, browser cleanup. Final summary. Selenium security is important because browser automation often touches login, sessions, cookies, tokens, test data, screenshots, videos, and CI/CD secrets. Important concepts include no hard-coded credentials, no token logging, test accounts only, fake test data, least privilege users, browser state cleanup, screenshot video protection, CI/CD secret management, Selenium Grid protection, Docker container safety, HTTPS test environments. Beginners should remember. Selenium is powerful because it controls real browsers. That also means Selenium tests must be designed securely. Key idea. Secure Selenium testing protects credentials, sessions, test data, artifacts, and test environments while still validating real user flows.